Hello, welcome to Time classes. Today we are going to discuss the exercise of basic concepts of chemistry. There we will solve the problems based on language of chemistry. Okay, let's start. So let's look at the first question. And one more thing, you have to remember that always when you are attending the classes, you have to be ready with your notebook and pen and note down whatever our discussion is taking place. Fine, let's start. The first question is a fill in the blanks. So let's see the first fill in the blanks. The formula of ash acid containing nitrogen is, okay, first let us work out, because you know that nitrogen can form different oxyacids. Now which oxyacid we are choosing, depending on that it should be acid or ic acid. So formula will be based on that. So let's start from there. So what are the different oxyacids can nitrogen form? Let us write here. They are HNO2 and HNO3. The acid contains less number of oxygen atom, then we use as suffix if the along with the name of the non-metal. Here the non-metal is nitrogen, and if the acid contains more number of oxygen atom, then we use IC, ic suffix along with the name of the non-metal, that here it is nitrogen. Fine. So here formula of ash acid is asked. So it is obvious that where there is less number of oxygen, that oxyacid will be the ash acid, will have the ash suffix, right? So what is the formula of the ash acid of nitrogen? It is HNO2. Fine. So let's see the answer and then we'll move on to the next question. Answer is HNO2. Fine. Now let us look at the next question. The next question is the symbol of tungsten. So while writing the symbol, either you have to write the name of that particular element. Tungsten, sometimes in case of certain elements we use their Latin name, their German name, their English name or their Greek name. So for tungsten we use the German name. What is the German name for tungsten? You must have studied in the basics. So let us write the name of the German name of tungsten first. So what is that? That is Wolfram. Wolfram. So according to the rules for writing the symbol, the starting letter, the initial letter, the first letter, that is W in the capital is the symbol. So there are different ways of writing symbol, but for Wolfram we use the first letter in capital, right? So let's check the answer. So W is the symbol, capital W. Let's check the solution and then move on to the next question. So solution is W, right? So we'll move on to the next question. What is the next question? The number of oxygen atoms present in a molecule of magnesium sulfate is. So for this purpose, what you have to do to know the number of oxygen present in magnesium sulfate, definitely you have to write the formula first. For writing the formula, first you have to know what are the ions present in the compound. Then only you can write the formula, right? So here what are the ions are there? Magnesium plus 2 and sulfate. So SO4 minus 2. So what is the formula? So formula is magnesium sulfate or MgSO4, right? So now it is very easy to find out the number of oxygen atom present in one molecule of magnesium sulfate. That must be 4. I hope you got the answer before me. Fine? Okay. So we will see the answer, then move on to the next question. So let's see the answer. So magnesium sulfate formula is MgSO4 and the number of oxygen atoms is 4 in one molecule. Fine? Okay. We will move on to the next question. So our next question is the Latin name of Mercury. The Latin name of Mercury already you have studied in basics. So Mercury symbol is, you know it very well. What is the symbol of Mercury? Let us write the symbol of Mercury first, Hg. So what should be its Latin name? Its Latin name is Hydrocarbons. Be careful about the pronunciation, because pronunciation is very important to derive the symbol of the element. Fine? Okay. So let us see the solution. Hydrocarbons. Note it down carefully, and you should not make any mistake while writing the spelling of the name of the element. Fine? Okay. So now we will move on to the next question. Our next question is the name of the higher oxide of copper. So copper can form two different oxides. You know that copper has variable valency. That's the reason it can form two different oxides. So one is Cu plus, another one is Cu plus 2, right? The element present in the oxide, if it exhibits its lower valency, then we call it as lower oxide, and in the oxide, if its valency is higher, then we call it higher oxide. Clear this is? Okay, fine. Now let us work out on the formula first, although the name of the higher oxide is asked, but let us work out also, that will be learning for you. Suppose Cu plus 1 and O minus 2. Oxygen valency you know, minus 2. Now what will be the formula of the compound? It will be Cu2O. Fine. And the other one is Cu plus 2 O minus 2. So it will be CuO. Fine. So higher oxide means we have to consider this. Now coming down to the naming part. If the element has the lower valency, specifically the metal, if it has the lower valency, then we add OUS suffix with the name of the element. Here the name of the element is what? Cuprum. From cuprum we will remove and we will add as. Okay, that is for the lower oxide. For the higher oxide we use IC suffix. So for cuprum, UM will be removed and IC will be added. So it will be cupric. So for lower oxide cuprux, for higher oxide cupric. So the name of the higher oxide of copper is, it is definitely, I think you are ready with your answer. It's cupric oxide. Fine. So let's move on to the, first see the answer, cupric oxide, and then we will move on to the next question. Which of the following ions has the least valency? Okay. Now it is a multiple choice question, because let us see the options. We need to see the options. Ammonium, barium, aluminium, calcium. Now let us work out. We know already we have started in basics, so we have to first write the formula of the symbol of the elements. For ammonium, it is a positive radical. We have to write the formula along with the charges. See, ammonium, NH4, valency, I am waiting for you, plus 1. Aluminium, symbol is Al. Please work out with me. Before I write, you should be able to ready with your answer. Aluminium plus 3. Barium, Ba plus 3. Sorry, barium is Ba plus 2. Now calcium is Ca plus 2. Now least valency, look at this. Here it is 3, here it is 2, here it is 2, here it is 1. So the least valency is associated with the ammonium ion. So what is the choice? Let us see the choice and then we will move on to the next question. Choice 1. Let's look at the next question. Which of the following is a sulfite ion? Let us see the options. Options are, you can see S minus 2. Now one thing I would like to recollect, that if only the element is used, the negative radical is formed only with that particular non-metal, then we use IDE suffix, right? Now see, here oxygen is there in option number 2 and option number 3 oxygen is there. Option number 4 also there are oxygens, but this is, you can see that number 2 is SO3 and number 3 is SO4. Only difference in the oxygen number or number of oxygen atoms. But in the 4 it is S2O3. It is structurally a bit different. So let us write first the name of this one, S2O3. which is not coming into your category what you have studied. So this is called thiosulfate. Thiosulfate. So H2O3 minus 2 is thiosulfate. Please note it down. Now, if only the element is there, id suffix, so what is the expected name of this radical? The first one, choice one, it is sulfide. Sulfide. Number 2, now again that less number of oxygen, more number of oxygen, 2 and 3. In 2 there are 3 oxygen atoms. So definitely the suffix will be ITE. If less number of oxygen, then the suffix is sulfite, ITE. If more number of oxygen atoms are there, then ATE, sulfate. And already we have seen thiosulfate is the 4th one. So our required one is sulfite. So it is nothing but the second one. Okay, let's see the solution and we'll move on to the next question. Choice 2, fine. So let us move on to the next question. Identify the radical associated with -3 valency. Let us work on it. See the options. So first what we will do, you must be ready with your answers. So first thing is you have to write finding out the valency, you have to write the symbol and along with their valencies. What is peroxide? O2 minus 2. Before me you are supposed to write oxide, O minus 2. Nitrite, just previous question we have discussed. NO2, less number of oxygen atom, valency minus. Nitride, id is suffix, so only element, so it is N and valency is -3. Okay, so we have seen all the valencies. Now we have to find out the radical with -3 valency. So definitely the 4th option is the correct option. Let's check the solution and then move on to the next question. Choice is 4. Move on to the next question. Next question is, which of the following does not exhibit variable valencies? Let us see the options. So options are copper, iron, manganese and zinc. So let us first see that which element has variable valencies, and then we can easily identify which doesn't have. Copper, already you know, just 2-3 questions back we have already discussed about copper, variable valency of copper. So it is Cu plus, C is capital, U is small, Cu plus 1 and Cu plus 2. C must be capital, Cu plus 2, right? For iron, Fe plus 2, Fe plus 3, right? For manganese, Mn plus 2, Mn plus 4. For zinc, only one valency, Zn plus 2. So which does not exhibit variable valency must be the 4th option. Let's see the option and then move on to the next question. So it is choice 4 and let's look at the next question. Understood everybody? Okay. How many atoms are present in calcium biphosphate? For that, before seeing the options, we will work out first. Because without options also we can work out. Calcium biphosphate, for counting the number of atoms, we should know the correct formula. So for knowing the correct formula, you should know the ions present in it. So what are the ions present in it? Let's start working on it. So it is calcium, its valency, I'm waiting for you, plus 2, right? Biphosphate. For biphosphate, I'll tell you one thing. First you write phosphate radical, which is well known, okay? PO4 minus 3. I am not writing minus 3 because it is not phosphate, it is biphosphate. Biphosphate means hydrogen phosphate. So I have to add one hydrogen here. The moment I am adding one hydrogen, hydrogen is coming with a positive, 1 unit of positive charge. So phosphate radical has -3 charge. Along with that, one hydrogen is added with the +1 charge. So resultant charge is -3 + 1 -2. Fine. Now formula very easy to write. Ca + 2 HPO4 -2. Fine. Then what will be the formula? +2 -2 CaHPO4. Now count the number of atoms. 1 calcium, 1 hydrogen, 1 phosphorus. 3 plus 4 oxygen atoms. So it is 7. So let's look at the answer and then we will move on to the next question. Options are 5, 6, 7 and 8. Let's work on it. See the solution. Solution is 3. So it is 7. Very good. So let us move on to the next question. Next question is, in which among the following compounds hydrogen shows a negative valency? So for this, what we need to have? We need to have the options first. So let's look at the options. H2SO4, HCl, HCO3, NH. Okay. So how will you decide that in which the hydrogen shows the negative valency? Generally, the positive ion in the formula comes first, like H2SO4. Here it is starting with hydrogen, so it should be H plus. There is an exception also that I will also discuss. So here it is H plus. Fine. Now sodium bicarbonate. Here if see, it is sodium is plus, bicarbonate is -1 here. Then what is the valency of hydrogen? Bicarbonate as a whole is -1. Carbonate is -2. Hydrogen is coming and joining with a plus charge. So the resultant valency is becoming -1. So here in sodium bicarbonate also the hydrogen is in the plus state, right? So sulfuric acid, hydrogen is in the plus state. In sodium bicarbonate, hydrogen in the plus state. In HCl also, it is starting with hydrogen. So here also hydrogen is in the plus state. Here you see it is starting with sodium. Not only that, sodium is more electropositive than hydrogen, you know already. So sodium should have positive charge and hydrogen should have negative charge. So hydrogen shows a negative valence in which option? The fourth option. I told you that one exception I will tell you. So before that, what I told, that generally the compounds start with the positive valency, positive radical first, then the negative radical. But there is an exception, ammonia. Here nitrogen is -3 and every hydrogen has +1 valency. Since there are 3 hydrogens, so +1 into 3 +3 and -3, compound as a whole is neutral. So remember that and make a note of it. Fine. Noted down? Okay. So now we will see the option and then move on to the next question. What is the option? Option is 4. Fine. Okay. Now let us move on to the next question. The formula of hypochlorous acid is, here also we can work out without options. Now get set ready with your pen and then how many oxyacids? Hypochlorous, it indicates that it is an oxyacid. How many oxyacids can chlorine form? Let us jot down that. So this is HClO. This is one oxyacid. HClO2, another oxyacid. HClO3, the third one. The fourth one is HClO4. Okay. Now let us see the naming. Look at the second and third. Less number in between this second and third one, the less number of oxygen is here, HClO2. Here we will add as suffix with chlorine. Second one, 3 oxygen atoms are there, so we will add IC suffix with chlorine. Fine. So the second one is chlorous acid, the third one is chloric acid. Now coming down to first and fourth. How will you name? So the oxyacid which contains less number of oxygen atom than the corresponding as acid. For naming that, we use hypoprefix. So hypoprefix and as suffix. Please note it down. It is very much required for working out with the oxyacids of chlorine. So hypoprefix and as suffix. So what should be the name? Hypochlorous acid. Second one chlorous acid. Third one chloric acid. HClO4. If the oxyacid contains more number of oxygen atom than the ic acid, then we use par prefix and ic suffix. Note it down, make it a point, remember this. So par prefix and ic suffix means what should be the name? Perchloric acid. So first one is hypochlorous acid, second one chlorous acid, third one chloric acid, fourth one perchloric acid. Fine. So the formula of hypochlorous acid is very easy to identify now, HClO. Sometimes you will find HOCl also. Don't get confused. Any of these two things you can write. Okay. Let's see the options and then solution. HClO, HClO2, HClO3, HClO4. So which choice? Good. Choice 1. And everything, I hope everything you have noted down. So please write along with me. Okay. So I am moving on to the next question. Choice 1 and see the next question. The number of nitrogen atoms present in one molecule of zinc nitride is. So zinc nitride. First you have to write the formula of zinc nitride. Later on we will see the option. What is the valency of zinc? Zn is +2. What is nitrite? NO2 -1. So nitrogen with less number of oxygen gets ITE suffix. So nitrite is NO2 -1. So what is the expected formula? Crisscross method, Zn NO2 taken twice. So this is called zinc nitride. Okay. So number of nitrogen atoms, remember that here it is nitrogen atom. In previous one question we have seen oxygen atoms. Here it is nitrogen atoms present in one molecule of zinc nitride. So NO2 taken twice. So N 2 times we are taking. So number of nitrogen atom in one molecule of zinc nitride is 2. Now we will see the options, solutions, and then we will move on to the next question. Options are 1, 2, 3, 4. And what is the choice then? So 2 are there. So second option is the option, choice 2. Let's look at the next question. Total number of oxygen atoms present in one molecule of magnesium perchlorate. So here also without option, first we will see the formula. So for writing the formula, you need to know the positive and the negative valency. So let's start. So first it is, what is the positive radical present in it? It is magnesium plus, right? Magnesium +2. Magnesium valency is 2. So magnesium +2. What is the formula of perchlorate? This is important. Perchlorate. Just in the previous question we have studied about chlorate, perchloric acid. So from the perchlorate radical gets generated from perchloric acid. So the formula of perchlorate is ClO4 minus C capital. One thing I am telling you time and again, because since C small and C capital are almost they look same. So that's the reason you have to be very careful while writing C. It capital C. It's a bigger C you have to write. So ClO4 minus. So let us write then Mg +2 and ClO4 minus. So what should be the formula? Mg ClO4 taken twice. Good. So the number of oxygen atoms present in one molecule of magnesium perchlorate, see, ClO4 radical is taken twice. In one radical 4 oxygen atoms are there, so in 2 radicals how many oxygen atom? 4 into 2 is 8. So the answer should be 8. Okay. Let's look at the options. 5, 3, 2, 8. So option is 4. Good. Choice 4. So let us look at the next question. In which of the following the magnitude of valencies of positive and negative radicals is the same? So for this we need to have the options. So let's see. Zinc oxide, magnesium phosphate, sodium sulfate and calcium nitrate. So what I have to do first? You must be ready with your answer. You have to write the formula. Good. So let us write the formula of each option. Zinc oxide. So zinc oxide is Zn plus 2 O minus 2. Tell me the formula. Must be ZnO. Good. Magnesium phosphate. Mg plus 2 phosphate, already we have discussed, PO4 minus 3. So what should be the formula? Mg crisscross, Mg3 PO4 taken twice, magnesium phosphate. Then sodium sulfate, sodium Na plus, sulfate SO4 minus 2. What should be the formula? Crisscross, so Na2SO4. Calcium nitrate, Ca plus 2, nitrate is NO. Tell me, NO3, because nitrate, AT is suffix, so more number of oxygen. Nitrite NO2, nitrate NO3. Nitrite NO2 minus 1, nitrate also NO3 minus 1. So what is its formula? Crisscross method, CaNO3 taken twice. Remember that this C is capital, this C is capital. Symbols always start with capital letter. Fine. Now see the question. In which of the following the magnitude of valencies of positive and negative radicals is the same? Here plus 2 minus 1. Magnitude is not same. Here plus 1 minus 2. If we don't write any number, that means it is 1. That is also not same. 2, 3, not same. Zinc oxide 2, 2. So our option is first one. Understood? Chalo. Next question we will see. So first look at the solution and then we will move on to the next question. So choice is 1. Okay. Next question let us look at. Next question is the molecular mass of potassium dihydrogen phosphate. So for that what we need to do? We need to first write the formula and then the calculation of the molecular mass. I will tell you how to calculate it. First let us write the formula. So potassium is, you know what is the valency of potassium? First you will write, then I will write. Plus 1. I think you are correct, right? Dihydrogen phosphate. Here one more phosphate radical derived from phosphate radical we will see. Dihydrogen, that means 2 hydrogen atoms are there, right? If 2 hydrogen atoms are there, so you have to write here H2. 2 hydrogen atoms are coming with 2 positive charge. Phosphorus has minus 3 charge. Along with that 2 positive charges are added. So what will be the resultant charge? Minus 3 plus 2. So it is minus 1. Fine. So K plus 1 H2PO4 minus 1 crisscross method. So formula is KH2PO4. Now how will you calculate the molecular mass? For molecular mass you need to know the atomic masses. Atomic mass I will write, molecular mass you will calculate. Note down, potassium is 39, hydrogen atomic mass is 1, potassium atomic mass is 39, hydrogen is 1, phosphorus is 31, oxygen is 16. Now you will work out. Started? Okay. Just first you do then I am telling you the points where you have to be careful. In the formula, potassium is only one atom, so we will add 39 as it is. Hydrogen is 2, that means 1 into 2, right? Plus phosphorus is 31 plus oxygen is 4, that means 16 into 4. So you can see hydrogen 2 atoms are there, so we have multiplied by 2. Oxygen 4 atoms are there, so we have multiplied by 4. But potassium and phosphorus only single atoms are there, so 39 and 31. Then we have to add all. But before that you have to do the multiplication part. 39 plus 2 plus 31 plus 64. Calculate how much it is. I think you are ready with your answer. Let's look at the options. 136, 140, 152, 135. What is your answer? I think you got it. Let's check the solution. Choice 1, it is 136. Fine. So mark your answer, 136. Fine. Good. So we'll move on to the next question. Fine. Let's see. How many ammonium radicals are present in one molecule of ammonium phosphate? Here also you know that you have to write the formula of the compound first. Then we will see the options. Okay. So when we are writing the formula, then we have to know the radicals. What are the radicals here? The positive radical is ammonium. So it is NH4 plus. Phosphate, PO4 minus 3. Many a times we have discussed. So what is the formula then? Crisscross method. NH4 plus 1, PO4 minus 3. So it is NH4 taken how much? I am waiting for your answer. 3 PO4, right? So how many ammonium radicals are there? NH4 taken thrice, that means 3 radicals are there. Now we'll see the option and the solution. 1, 2, 3, 4. So choice is 3. Very good. Let's move on to the next question. Identify the odd one out with respect to valency. Here we have to see the options. Sulfide oxide, zincate carbide. Let us work out. First what we will do, we will first write the symbol or formula along with their valencies. Sulfide S minus 2, oxide O minus 2, zincate and carbide. You have studied in the basics, so I am expecting you to write the answer. Zincate is ZnO2. What is the valency? Minus 2. Carbide C minus 4. So which one is the odd one out? Definitely this one. Let's look at the option. Everybody copied it? Okay, fine. So it's not copying. You have to write before me. Okay, so I'm giving you some time. Write that and then tally your solution with me. So what is the answer? The fourth one. Okay, fine. So let's see the options. Choice 4. Now we will move on to the next question. See the next question. Mercurous oxide is. I will not give you the option. First you will write the its formula. Again variable valency. What is the formula? Symbol of mercury? Symbol is Ag, hydrargyrum. Now it can have 2 different valencies. One is plus 1, another one is Ag plus 2, right? So if it is mercurous, as suffix related to lower valency, already discussed, so plus 1. Higher valency, what is the suffix? I think you are ready with your answer, ic. So mercurous, mercuric. So this is us. So oxide means O minus 2. So what will be the formula? Ag, crisscross method, 2O. So mercurous oxide is Ag2O. Now we will see the options and the solution. AgO, HgO2, Hg2O, Hg2O2. So which option? 3. Choice 3. Let us move on to the next question. Which of the following pairs have the same valences? For this we have to know the option. So let's see. Sodium, potassium, sodium, calcium, potassium, zinc, barium, aluminium. Now we will work out. We have to write the valences and then check. Sodium and potassium, you know, +1, +1. Sodium +1, calcium, tell me. I'm waiting for you. +2. Potassium, already I have written, so I'll write zinc, so many times discussed, +2. Barium, +2, aluminium, +3. So where you are finding the same valency? Definitely choice 1. Correct. So now we will see the solution and then move on to the next question. Solution is choice 1. Done everybody? Okay. Next, define symbol. Now we will discuss certain questions which are where you have to write something, write a statement, a couple of statements or a single statement, and we will try to understand that also. It is a definition, define symbol. First let us understand what is symbol. Symbol is nothing but it represents one single atom of an element. It is a shorthand notation. Symbol is a shorthand notation to represent one single atom of an element. So now let's see what is the definition. So it is symbols are the shorthand notations representing a single atom of an element. Now for every definition there are some key points what you must mention. If you forget to write that, your definition will not be complete. Shorthand notations and a single atom, both are very important aspects of this definition. Shorthand notation, single atom. Suppose if I write suppose sodium symbol is Na. If I write Na, then it is showing one single atom. If I write suppose 6 Na, that means when this coefficient 6 is representing 6 atoms of sodium. One more example I will give you. Oxygen, it is a symbol. O, it is a symbol, right? Oxygen is a symbol. Now if I write O2, why do I write O2? Because oxygen is a diatomic molecule. Diatomic molecule means its atomicity is 2. In one molecule there are 2 atoms, right? So this is, now this will be formula. This is no longer a symbol. This becomes a formula. But O is the symbol of oxygen. I hope it is clear to you. Fine. Noted down the definition of symbol. Okay. We'll move on to the next question. Write the valences of the following radicals. Let us look at the radicals. Phosphate, zincate, biphosphate, silicate. So, valences. First we will write the formula of these radicals along with their valences. Then we will, that is a question which is asked. Okay. So, let's write. Get set ready with your pen. Phosphate, PO4 minus 3. I have started, but next one I will not tell you. Zincate. I'm giving you time. I'm writing very slowly so that you write before me. ZnO2 minus 2. I think you are ready. Biphosphate. Magical. PO4. Put hydrogen here. Only one hydrogen. Hydrogen is contributing plus charge. So minus 3 plus 1. It is minus 2. Silicate. We didn't discuss this in this class. So I am just writing it. SiO3 minus 2. Fine. So now write the valences. So here for phosphate it is minus 3. Biphosphate it is, this is the biphosphate one, minus 2. Zincate minus 2. Silicate also minus 2. Fine. Okay. Now let's see the solution. Solution: minus 3, minus 2, minus 2 and minus 2. Fine. Okay. Everybody has written the answer on your own? Okay, fine. So we'll move on to the next question then. Among the following, identify the elements which show variable valencies. Okay, so for this we need to see what are the elements. These are the elements. Now we will write. Copper. Is there variable valency? So many times I have discussed. So copper, C capital. Be careful when you are dealing with C because small and capital look same. Cu plus 2. You have to write a bigger C. Zinc, only 1 plus 2. Okay. So zinc doesn't show the variable valency. Cobalt, capital C, plus 2 and plus 3. Okay. Shows variable valency. Iron, plus 2 plus 3. Tin, plus 2. What is the other one? Plus 4. You must be ready with your answer before me. Pb plus 2, Pb plus 4. Barium. Barium is Ba plus 2, only one valency, not variable. Aluminium, Al plus 3. So what are the identify the elements which show variable valencies. So copper, cobalt, iron, tin and lead. Okay, let's see the answers. Noted down everything. I'm giving you some time. You must be writing with me. Fine? Okay, let's see the solution. Solution is copper, iron, tin, lead, cobalt. Fine? Okay, let's move on to the next question. How are chemical changes represented in short form? Chemical changes, when we write, we need to write the elements and the compounds. How can we represent an element in short form? By using its symbol. How can you represent a compound in its short form? By using its formula. So chemical changes can be represented with the help of symbol in case of element, formula in case of element as well as compound. Just example. Oxygen already I have discussed. Okay, I will not take oxygen then. I will take another element. Let us take as phosphorus. This is symbol. If I write P4, it becomes formula. So P is symbol, P4 is formula. Formula again represents the atomicity also. How many atoms are there in one molecule of phosphorus? So this is atom, P is atom, P4 is molecule. Here lies the difference. So chemical changes can be represented in short form with symbol in case of elements. In case of element and compound, it can be element or a compound, we use formula. So, and now the one what we are writing, that is called chemical equation. So let's see the solution. Solution is chemical changes are represented in short form in the form of chemical equations by using symbol and formula. Fine? Good. We'll move on to the next question. Okay. So what is the next question? The formula of a metal carbonate is MCO3. Determine the formula of its chloride, nitride. Okay. Let's check. So for writing the formula chloride and nitride, you must know the valency of the metal. How will you get to know the valency of the metal? From the given compound MCO3. Let's start working out. Sorry, MCO3. Now M is unknown. We don't know which metal it is. So we do not know the valency. So how will you work out? Based on the given one, known one. CO3 is known. So CO3 is carbonate radical. What is its valency? Its valency is -2. So M should have a valency. I will not tell you. You will answer. MCO3 is the compound in which CO3 has -2 valency. What should be the valency of M? Compound as a whole is neutral. Obviously, it should be +2. So M +2. Now chloride and nitride very easily we can write, because now we know the valency of the metal and negative radicals are given. So first let us work out chloride. M plus 2 Cl chloride, C capital L small minus. So the formula is, I am waiting for you, MCl2 nitride, M plus 2 nitride is N minus 3 crisscross M3N2. We are done with this. Okay, noted down everything. Let's see the solution. Fine, good. Solution is, the valency of the metal in the carbonate is 2, chloride is MCl2, nitride is M3N2. Okay, so let's move on to the next question. Let's look at the next question. So next question is, calculate the ratio of number of metal atoms to the non-metallic atoms in the following compounds. So let us work on it. Okay, then we'll look at the solution. So let's first start with the first compound. What we will do first, we will first write the formula of the compounds, then only we can calculate the ratio of metal atoms to non-metal atoms. So first one is ammonium carbonate. So let us write NH4 plus and carbonate is CO3 minus 2, right? So what will be the formula? The formula is NH4 plus and CO3 minus 2. So it is NH4 taken twice CO3. I hope you have written already the formula. Okay. So number of metal atoms to non-metal atoms, there is no metal atom. So number of metal atoms is 0. Non-metal atoms are NH4, means 1 nitrogen atom, 4 hydrogen atoms. So 5 2s are 10 plus carbon 1, 11, 3 oxygen atoms, 11 plus 3, 14. So 0 by 14, answer is 0. Now next is potassium dihydrogen phosphate. Potassium is plus 1, dihydrogen phosphate is H2PO4, and PO4 is minus 3, 2 hydrogen ions are getting attached. So minus 3 plus 2, resultant charge is minus 1. So formula is KH2PO4. So this, look at the metal atoms, only one metal atom is there. So numerator is 1. Okay. So let us write it properly. 1 divided by total number of non-metallic atoms, 2 hydrogen atom, 1 phosphorus, 1 phosphorus atoms. So 2 plus 1, 3 plus 4 oxygen atoms. So 3 plus 4, 7. So this is 7. 1 by 7. Second one, potassium permanganate. This one is potassium permanganate. Let's do the first column, then we'll go to the second column. So potassium permanganate, in that potassium is K plus 1, manganate is MnO4 minus 1. If it is permanganate, MnO4 minus. If it is manganate, MnO4 minus 2. Okay. So what will be the formula? It is permanganate, so it is potassium permanganate plus 1 minus 1. So KMnO4. So number of metal atoms 1 plus 1, 2. So numerator 2, denominator 4 oxygen atoms are there. So it is 4 is equal to 1 by 2. Fine. Next is calcium hypochlorite. Calcium is Ca plus 2, hypochlorite is ClO minus, crisscross method CaClO, C capital, always remember that, CaClO taken twice, because calcium valence is 2, ClO valence is 1, right? So number of metal atoms is 1. So let us write here 1. Numerator, denominator is 1, 2. 1 chlorine, 1 oxygen, and it is taken twice. So 2 into 2 is 4. So this is 1 by 4. Sodium dichromate. Sodium is Na plus 1. Dichromate is Cr2 dichromate Cr2O7 minus 2. Okay, so what is the formula? Na2Cr2O7. Here what are the metals? Sodium and chromium, both are metals. So Na2Cr2 means 2 plus 2 4. So sodium dichromate, for that numerator is 4, denominator is 7, because oxygen 7 atoms are there. So 7, 4 by 7. Okay, done. Now I am giving you some time, you understand and write it down, then we will check the solution. I hope you have written everything. Okay, because you have to write along with me. You need not wait for finishing my writing and then you are writing. It should not be like that. It should be simultaneously with me. Fine. Let's look at the solution. Solution is first one 0. Sorry, let me go back. First one is 0. Second one is 1 by 4. B, calcium hypochlorite 1 by 4. Potassium dihydrogen phosphate 1 by 7. Then sodium dichromate 4 by 7. Potassium permanganate 1 by 2. You could understand, right? Okay, we'll move on to the next question. Now we will start very challenging questions. Okay, first question. A metal ion combines with a negative radical containing a chlorine atom. Okay, so let's start. So metal atom, what is its valency? We do not know, so we'll write just M. Chlorine atom, and negative radical contains chlorine. What else are there? Let us see. If the number of oxygen atoms in one molecule of the salt is 8, okay, find the valency of the metal and identify the negative radicals. Now chlorine, and see, if the number of oxygen atoms means oxygen is there along with chlorine, so what are the radicals possible? There are 4 radicals possible: hypochlorite, chlorite, chlorate and perchlorate. All are -1 valency. Fine. Now it is given that in one molecule of the salt there are 8 oxygen atoms. See, first one, if we consider hypochlorite, then for 8 oxygen atom, these has to be taken 8. That means metal valency must be +8 and ClO. See, look at all the negative radicals. Everywhere the valency is -1. So if metal valency is 8, then only it is MClO taken 8 it is possible. With the 8 valency is not possible for any of the elements. So this is ruled out. Second one, let us consider. Then it has to be MClO2 taken 4. Right, C is capital, taken 4. That means the valency of metal here is +4. +4 is possible. The stannate, Sn +4, and stanics, it's not stannate, it's stannic and plumbic. So Sn +4 is stannic and Pb +4 is plumbic. So possible that the metal can have +4 valency. So this could be one of the possibility. Chlorate, MClO3. Now 8 is not a multiple of 3. So this is not at all possible. Let's look at the next one. ClO4, very much possible. ClO4 taken twice. So oxygen atom will be 8, C capital here. Okay, remember that. So here what is the valency of the metal? +2. So +2 and +4, both the valencies of metals are possible. 2 is more common, 4 is little uncommon, but it is possible. So what are the options possible? It can be ClO2 minus, chlorite, or ClO4 minus, ClO4 minus. It is perchlorate. So chlorite or perchlorate. So let us check. What you have to check? Find the valency of the metal and identify the negative radical. So if it is ClO2, that is chlorite, then the valency of the metal should be +4. If it is perchlorate, then its valency is -1 and the metal formula of the compound is MClO4 taken twice, so metal valency should be +2. Fine. Let's see the solutions. Solution is negative radicals could be ClO2 minus, ClO4 minus. I hope you could understand from the explanation. Next, the formula of the salts can be MClO2 taken 4, MClO4 taken twice. Fine. Next, the valency of the metal could be 2 or 4. I hope you could understand and enjoyed the problem also. Fine. Is it challenging? Of course. Let's move on to the next question. A salt is made up of a negative radical containing chlorine and it is associated with 3 oxygen atoms. So we can easily identify the negative radical because already we have discussed in the previous question. So get set ready with your answer. Negative radical present in it is ClO3 minus, that means chlorate. It is chlorate, right? Now the positive radical present in it made up of 2 non-metallic atoms. Okay, 2 non-metallic atoms means it should immediately strike your mind the positive radical. There are only 2 positive radicals, hydronium H3O plus and NH4 plus. So NH4 plus is the desired one. What positive radical made up of 2 non-metals used here, NH4 plus. Okay, so NH4 plus ClO3 minus. Now what will be the formula of the compound? NH4ClO3. Okay. Now let us see so we could identify the formula of the compound. Which of the following statements is or are true regarding the salt? So this is the salt. Let us see the options. Both the positive and negative radicals are monovalent. Is it correct? Of course it is correct because it is NH4 plus and ClO3 minus. So monovalent. Now next option, negative radical is generated from perchloric acid. Is it correct? No. If it is from perchloric acid, it would be ClO4 minus, but it is ClO3 minus, so it is generated from chloric acid. So B is not correct. Fine. So A is correct, B is not. Let's see the next one. The total number of atoms in one molecule of the salt is 9. Is it 9? NH4ClO3. Okay, so let us check it. So nitrogen 1, hydrogen 4. So it is 4 plus 1, 5 plus 1 chlorine plus 3 oxygen atoms. So 5 plus 4, 9. So this statement is correct. Let's move on to the next question. Next statement. The number of negative radicals present in one molecule of the salt is 2. Negative radical, is it 2? No, because NH4 plus ClO3 minus. So NH4ClO3. So negative radical present is only 1. So this is also the fourth option. Fourth statement is not correct. Okay. Let us look at the next statement. Next statement is the name of the negative radical has ATE as a suffix and does not have a prefix. So what we have already discussed, chlorate, it's not perchlorate, it is chlorate. So it has ate suffix but no prefix. Fine. So this statement is also correct. Fine. Let's check the solution and then move on to the next question. I hope you understood and enjoyed the problem also, right? Okay. So check the solution. Solution is the negative radical is ClO3 minus. Positive radical NH4 plus, salt is NH4ClO3. Both the positive and negative radicals are monovalent. The negative radical is generated from chloric acid, not perchloric acid. Total number of atoms present in one molecule of the salt is 9. In the salt NH4ClO3, the number of negative radical present is 1. Since the name of the negative radical is chlorate, so it has ATE suffix and no prefix. Okay, so ACE and ACE are true. Okay, let's look at the next question. Next question is, an anion is formed when one hydrogen atom is replaced from one atom of sulfuric acid. Let us identify the anion. Okay. So how will you identify the anion? First you have to write the formula of sulfuric acid, H2SO4. From this the anion is generated. So by the replacement of one hydrogen atom. So the anion generated from this is HSO4 and its valency. See, compound as a whole is neutral. So H2SO4 is neutral. When one hydrogen atom with a plus charge is removed from it, then it will have a -1 charge, isn't it? So HSO4 -1. And this anion is present in a salt containing a bivalent metal M. So unknown metal M, but it is said that it is bivalent. So we can write its valency M+2, right? Now M+2 HSO4 minus. So what will be the formula of the compound? MHSO4 taken twice. So calculate the number of oxygen atoms present in one molecule of the salt. So what is the number of oxygen atoms? You can see that in one radical it is HSO4 and it is taken twice. So 4 2s are 8. So total number of oxygen atom is 8. So this is the answer of this question. Let us look at the next question of this section. So the next question is, the valencies of a metal ion A in two different oxides X and Y are 2 and 3 respectively. Calculate the number of oxygen atoms present in 4 molecules of X and 5 molecules of Y. Fine. So that means that the metal ion A, it has variable valency. So what are the valencies? Let us identify. Okay, and identify the formula of the oxides also, X and Y. So two different oxides. Let us take first one, X. In that the metal valency is 2, right? So metal is A plus 2 and oxide means it is O minus 2. So what will be the formula of X? X must be AO. Clear? Understood? Next one, you work out. Now the metal valency is said in Y, it is said that it is +3. So A plus 3, oxygen remains as it is, minus O minus 2. So what will be the formula of the compound? Compound is nothing but Y. So it is crisscross method. So it will be A2O3. So Y is A2O3 and X is AO. Fine. Now calculate the number of oxygen atoms in 4 molecules of X. Let us write here 4X, that means 4AO, and 5 molecules of Y. So 5Y means 5A2O3. Let us write it clearly, 4AO and 5A2O3. So we have to calculate the number of oxygen atoms. So in 4AO there is, very easily you can understand that, 4 oxygen atoms, and in 5A2O3, 5 3s are 15 oxygen atoms. Here it is 4 oxygen atoms, here it is 15 oxygen atoms, right? So let's move on to the next question of this section. Next question is, a silicate contains a silicate salt Y contains a trivalent metal A. Let us jot down. So metal is trivalent and it is A. So it is A plus 3, and a monovalent metal B. So B is plus 1. How many oxygen atoms are present in one molecule of Y? Y is what? The silicate salt. In that A plus 3 is present and B plus 1 is present. So total charge contributed by A and B together is plus 3 plus 1 is plus 4. So non-metal also, the anion, the negative radical also should contribute a -4 charge. Let us see. So negative radical is SiO3. SiO3 minus 2. So positive charge is plus 4. So negative charge should be -4. That means we have to take 2 SiO3 radical. So what should be the formula? AB SiO3 taken twice. So the total charge of A and B are 4. +4 and 2 SiO3 will contribute -4 charge. So compound as a whole is neutral. The formula of the compound is AbSiO3 taken twice. Let's look at the solution of the three questions. First one, the anion formed from when one hydrogen atom is replaced from sulfuric acid is HSO4 minus. Fine, good. The cation is bivalent. So the formula is MHSO4 taken twice. So the number of oxygen atom in the one molecule of salt is 8. Done? Next question. The formula of X is AO. The formula of Y is A2O3. 4 molecules of X have 4 oxygen atoms. 5 molecules of Y has 15 oxygen atoms. Next question. The formula of Y is, that means the compound is BaSiO3 taken twice. One molecule of Y contains 6 oxygen atoms. That you could understand, I think. That, see, in one molecule SiO3, one radical contains 3 oxygen atoms. 2 radical will obviously contain 3 into 2 is equal to 6 oxygen atoms. Done? Okay, very good. Clear? Note it down. Okay, let's move on to the next question. The salt on heating releases carbon dioxide gas. That means the salt must contain a radical called carbonate. If in a salt carbonate radical is there, then it can release carbon dioxide gas. Not always. Sodium carbonate, potassium carbonate, they do not release. But most of the carbonates, we can say that when you heat them, they release carbon dioxide gas. So since the salt is releasing carbon dioxide gas, it must have carbonate radical. If one molecule of this salt reacts with 2 molecules of HCl, calculate the number of metal atoms present in one molecule of X, means the salt where carbonate radical is present, and determine the formula of X. Okay. So one molecule of the salt is reacting with 2 molecules of hydrochloric acid. That means 2 molecules of hydrochloric acid, how many chloride radical it can generate? It can generate 2 chloride radical, because each hydrochloric acid contains 1 chloride radical. Fine. Now let us assume that the metal is M. Okay. We do not know the valency. That's why we didn't write the formula of this compound. Only we know that just in the salt X, metal M is present and carbonate radical is present. We don't know the valency, we don't know the formula yet. But from the next statement we can conclude that this chloride salt, what is obtained when this carbonate salt reacts with hydrochloric acid, a chloride salt is formed. So this chloride salt contains 2 Cl minus radical. So the formula of the salt is MCl2. Which salt? When this X, that is the salt which contains carbonate radical, reacts with hydrochloric acid, the chloride salt formed, its formula is MCl2, because it contains 2 chloride radical. Fine. Now we can calculate the valency of metal M. So M has to have +2 valency, because chloride has minus valency and 2 chloride radicals are there. So metal should have +2 valency. So now we know the valency of the metal. Now we have to determine the formula of X. X means metal +2 is there and carbonate CO3 -2 is there. So what is the formula of X then? Very simple, MCO3. I hope you could follow it. Fine. Let's see the solution. Let the metal atom be M. The chloride salt produces MCl2, hence the valency of the metal is 2. The salt X is MCO3. One metal atom is present in one molecule of the salt. Yes. So since the formula is MCO3 in X, what is the formula of X? It is MCO3. So only one metal atom is present. Determine the formula of X and the number of metal atoms present in one molecule of X, that is 1. Done? Okay. Shall we move on to the next question? Yes. Okay. Next question is, one molecule of an oxyacid of sulfur has 3 oxygen atoms. Okay. Oxyacid of sulfur having 3 oxygen atoms. What should be its formula? I think you are ready with your answer. Very simple. H2SO3. What is its name? I am writing 2 oxyacid of sulfur. H2SO3, H2SO4. Now predict the name of H2SO3. More number of oxygen atom, Ic suffix, sulfuric acid. So this is sulfurous acid. So our acid is sulfurous acid. When it reacts with 2 molecules of KOH, let us write the reaction. H2SO3 plus 2 molecules of KOH. When they react, they will definitely form K2SO3 plus H2O. Okay. Because the salt, in the salt, potassium having +1 valency and SO3 sulfide radical is having -2 valency. The formula of the salt should be K2SO3, right? Now what you have to do, calculate the total number of atoms present in 5 molecules of the salt. So we have 5 molecules of K2SO3. So in one molecule, how many atoms are there? 2 plus 2 potassium atom plus 1 sulfur atom, 3 plus 3 oxygen atom. So 3 plus 3, 6. So this kind of atoms in one molecule. So in 5 molecules, 5 into 6 is 30 atoms are there, right? So calculate total number of atoms present in 5 molecules of the salt is 30. Fine. And the number of atoms of each constituent elements. Potassium, 5 2s are 10, so potassium is 10. Sulfur in one molecule it is 1, so in 5 molecules it is 5. Oxygen, 1 molecule 3, so 5 molecules 15. Done? So we are done with the problem. Let's see the solution. The acid is H2SO3. The reaction by which the salt is forming, the salt formed is K2SO3. 1 molecule of K2SO3 contains 6 atoms. So number of atoms in 5 molecules of K2SO3 is equal to 30. Potassium 10 atoms, sulfur 5 atoms, oxygen 15 atoms. So we are done with our solution. Could you understand? Enjoyed the question? Okay, very good. Thank you. I hope you could understand everything, and let us keep your right spirit and solve the questions and get ready with your basics before attending any exercise session. Fine? Good.